Students, I hope all of you are fine and doing well. The topic we will discuss today it is the silicons or its introduction. So let's have a look on the silicons. Basically, the word silicons is denoted that it is the compound of the silicon that is from group 4A elements. So a silicon or it is also known as the polysiloxane. It is the polymer made up of siloxane. Here is general formula of siloxane, which is R2SiO Si silicon and R2, where R it is mainly an organic compound. So silicones are mainly made up of silicon plus oxygen and plus alkyl groups, where alkyl groups are the group of atoms that we obtain by removing hydrogen from an alkane. When we have alkane, for example, here we have methane CH4. When we just remove one hydrogen from this, we gain CH3. So this is the methyl group as known as alkane and denoted by R. So here we can see that the R groups join with the group of atoms which SiO So here we can have silicon, oxygen and silicon along with the two alkyl groups on the both sides forming a long chain. The word here we have poly. Poly means simple, many, and mers mean units. So when many units just combine and forming the long chains, they are known as the polymers, and these are the polymers when siloxane combine with one another, and these are known as basically silicons. So here in this picture, we can have the silica whose formula is SiO2. Now what is silica in nature? Silicon just occurs in the form of silica, which is known as the sand. On the other hand, silicon is present in the metallic form. So silica is just reduced to produce the silicon metal. When the oxygen is removed, this process is known as the reduction and it just reduced to the silicon metal. At the end, when we have silanes or siloxanes, they form the silicons as these make the polymers or the long chains. On the other hand, here we have the silicon metal. It is working as a semiconductor. We use the silicon wafers and the solar cells. So this is the use of the main silicons. But on the other hand, when they make the long chains or combined in a regular manner, they changes into the silicons. Next we have the structure of the silicons. Here you can see that here we have the water molecule, then we have the silicon along with two chloride groups and two methyl groups and the water molecule. Then the silicon is just chloride ions replaced by the hydroxyl group, and now this hydroxyl group reacts with another group and changes into the long chains or the monomers and forming the silicons with the removal of the water molecule. So here these are mainly known as the siloxanes, and these siloxanes make the long chains and changes into the simple silicons. So in this the silicon hold the methyl groups along with that as the structure we just gained molecular formula CH3 4. It is just like to the carbon as the carbon was having four methyl groups in which CH3 4. Carbon is tetravalent in nature. Likewise, the silicon is also tetravalent in nature. And in this structure, you guys can see that the silicon is having like this CH3 2 and then we have the oxygen and here we have silicon and CH3 whole twice. This is the main structure of the silicons in which the silicon atoms join together with the help of the oxygen and they form a long chain structure. After this, the properties of the silicons here, they are water repellents. It means they are insoluble in waters. They are good insulators. Insulators mean that do not allow the heat to pass are known as insulators. The third one, they have non-stick and anti-foaming properties. They are non-stick in nature. It means they can be used in the manufacturing of the non-stick utensils that are used at home. On the other hand, they have high strength of silicon carbon bond. When silicon just join with the bond, that bond is too much strong and it is having high strength as well. Last one, they are resistant to oxidation. It means the silicons cannot be oxidized because the bonds are too much strong between them, which the silicon make with the carbon as silicon combined with the two methyl groups with the oxygen, and again the silicon combines with the two methyl groups. So the bond strength of the silicon and carbon is very strong, so that's why it is resistance to oxidation. After that, we have the uses of the silicons, that where we can use the silicons. First one use we have, it is used as insulating material. It do not allow the heat to pass out, so that's why it is used as insulating material. Second one, it is mixed with the glass fibers for the additional strength. So to make the glass strong, it is just mixed up with the glass fibers. Third one, used as laminates for printed circuit boards. As it is an insulator, so that's why it is used as lamination for the circuit boards. Then it is used for the encapsulation of the components such as the resistors, or all the resistors that are made up. It is used for the encapsulation because it is as an insulator. So that's why it is used for encapsulation of the components. Last one, it is used for the making of the non-stick coating for the domestic cooking wares or the utensils. On the other hand, we have also the different shapes of the silicons used in our houses for the freezing or for the different purposes. This is also used in the making of the many domestic cooking wares as well as the different cooking spoons. It is also used in the manufacturing of semiconductors, and it is also used as a compound which can join the two surfaces together or as a filler because it is resistant to heat. So this is all about the silicones. I hope you guys understand, and if you have any queries you may ask me about that. And the next topic we will discuss today, it is the semiconductors. For that time, you guys keep learning and have a good day.